So here we have the function f of t, which is defined as sine of t in the interval t lying between 0 and pi, and its value is 0 for t greater than or equals to pi. So for that, we are going to use the definition of the Laplace transform. So we know that the Laplace transform of a function f of t is defined as the integral 0 to infinity f of t times e raised to the power of negative st dt. So we have Laplace transform of our given function f of t. Now since this is piecewise continuous, so we're going to break the integral into two parts. So our first integral is going to run from 0 to pi, and within this interval the value of f of t will be replaced by sine t times e raised to the power of negative st dt, plus the second integral with the limits going from pi to infinity, and within this interval the value of the function f of t is 0. So we have 0 times e raised to the power of negative st dt. Now that the second integral will be 0, so we have to evaluate the first integral. So that's 0 to pi e raised to the power of negative st times sine t dt. Now, in order to evaluate this particular integral, we're going to take the help of one integration value. So if we have the integral e raised to the power of at times sine bt dt, then the value of this integral is given as, this is an indefinite integral, so this will be e raised to the power of at divided by a squared plus b squared multiplied to a sine bx minus b times cosine of bx plus c. Now if we compare our integral e raised to the power of negative st times sine t dt, so we're going to get here our a value is equals to negative s and our b value is equals to 1. So that gives us e raised to the power of negative st whole divided by a squared. So we have negative s squared, so that will be simply s squared plus b squared, which is 1. So we have s squared plus 1 in the denominator multiplied to a, so that's negative s multiplied to sine. I made a mistake here, so this is t, cosine of t, sine t minus b, b here is 1, so we have cosine of t. And we have to substitute the limits, so the lower limit is 0 and the upper limit is pi. So let's substitute the value of the limits. So this is going to give us, so we have e raised to the power of negative s, so t gets replaced by pi divided by s squared plus 1 multiplied to negative s times sine pi minus cosine of pi minus the lower limit, so we have e raised to the power of 0 divided by s squared plus 1 multiplied to negative s times sine 0 minus cosine of 0. Now we know the sine of pi is equals to 0, so this value will go to 0. Cosine of pi will be negative 1, so this is negative 1. Sine of 0 is 0, and cosine of 0 is positive 1. So we finally get e raised to the power of negative s pi divided by s squared plus 1 multiplied to, so we have negative of cosine of pi, so negative of negative 1 will be simply positive 1. We have minus e raised to the power of 0, so that will be 1 divided by s squared plus 1, and we have negative of cosine of 0, so that's negative 1, so the negative and negative 1 will make it positive 1. So finally we get e raised to the power of negative s pi plus 1 divided by s squared plus 1. So this is going to be the required Laplace transform of our function f of t given by sine of t within the interval 0 to pi and 0 for t greater than or equals to pi.